Welcome everybody to our 120th AIM Learn Fast webinar. This one we're going to talk about something I've been getting some questions on, and love to be able to do these and get some of this information into the webinars where we can have people search for and look at different ways of explaining things. And this one is about configuring and calibrating RayStudio 3 sensors. In this particular case, we're going to use all production software firmware, all of that obviously. And one of the areas that a lot of people struggle with is occasionally you have lots of ECU channels. Many people do, but a lot of sometimes you don't. And or your car may have a certain amount of ECU based information coming into your AIM data logger, but it may not have the brake pressure or the steering or a sensor you might want. So we certainly we have the opportunity, anything above a solo, to add these sensors to your car. We've talked about that a lot. I remember we talked about that quite a bit with Peter Krause when we were talking about vintage race cars. Obviously those things don't have that. So we have that ability. Wanted to chat about these 4 sensors specifically and actually go through them live. I've got an AIM device down here. It's an MXP connected to my computer. We're going to jump into RayStudio 3. We are going to show how to set up the channel settings boxes for each one, and then transmit it in, and then do a calibration. But the one we're going to focus on and spend a pretty good chunk of time, maybe half of our time on, is the fuel level sensor itself. I want to talk about what's special about that one. The others are fairly similar, but the fuel level one being the one that I've been getting a lot of questions on recently. It is endurance racing season, as it used to be kind of towards the end of the year, and now there's endurance racing all the time. So we're getting a lot of those questions all the time, but even more people do a little bit more endurance racing towards the end of their season. So let's chat about configuring and calibrating RayStudio 3 sensors. So just a little bit about me. I've been here doing all of these, obviously, but a lot of times I'm sitting in the back and helping out a little bit here and there. But I'm the AIM Sports National Training Manager. Been working here with AIM officially for about a little over 10 years now. But we were a strong user of their products since well before then, right? 2000 or so, we got started using the karting products with my son's racing, and then and moved on up through Micron 1, Micron 2, DRAC, and then into the sports cars. One of our family-owned Spec Miata down here in the lower left corner. My son drove that to the SCCA Runoffs Spec Miata National Championship at Topeka, Kansas in 2006. One of the best things that one of the highlights of our family little operation here, right? So, and it was not only myself, my wife Ruth, my son Andrew driving, but then down here in the lower right is a web seminar, on-site seminar that we were that I do a lot of before the current situation. But this right down here in the lower left corner is my nephew Robert Caddell, and he was there with me at VAC, BMW Prep Shop in Philadelphia, and he lives back there now, and he came and joined us for the webinar. So, but it was Robert that did all the prep on the cars. So, and then in my previous life, before Andrew came along and started to drive the race cars, and I retired from the seat, I raced off-road racing. So off-road racing was a big part of it. This is a 2-seater that I ran. That was for those of you in Northern California, this was out at the Prairie City OHV Park in Northern California, to the east of Sacramento. And I even did a little bit of roundy round paved oval racing in this Volkswagen Rabbit here. So that's a little bit of background on me. Sure, the data is what I like to do now, but there was a driving background in the background, and then also car ownership and doing some things with the kids that are racing as well. So all good times, right? Let's talk about, the first thing is I've created some documents that I've shared, fairly widely. We've included the links here. Robbie will link them into the chat box, no doubt, and then we'll have them for those of you that are watching later on YouTube. Down in the description box, all of these links will be in the live chat, as I mentioned, or in the YouTube description of these linked documents. So, and this presentation as well. The first one, I'm just going to go through what we're going to talk about real quickly, and then we'll go out and do individual ones live. But setting up and calibrating a steering wheel sensor. Obviously, we have to tell the data logger where is the sensor, what millivolts equals 180 degrees and 180 degrees the other way, and then we get the end value that is important to us, which is the steering angle, right? We'll talk a little bit more about that in just a moment, obviously. Calibrating a throttle position sensor. We need to know where 0, we need to know where 100%. So at the end of the day, while we're looking at our data, we know exactly what our driver input was as far as the throttle position. So and then of course the suspension sensor, not one that's used by a ton, but since it is set up and calibrated differently, I wanted to mention it. And you may have other sensors that you're going to calibrate and set up that are different than these three. These three are the main ones, but the process is exactly the same inside of the software. So these three, if you know how to do these three, you would know how to do virtually any of them, right? So keep that in mind. Let's at this point, I'm going to jump out of here. We're going to bring up Race Studio 3. Hope I have it running. I do. And let's talk about steering, throttle, and suspension, and go through the steps of how to create them and make them work for you. So what I want to do is I want to bring up first, just to open up a configuration that I have. This is one that I've used here in the past. It's just an MXP. I've got an AIM data logger powered up over here, and I've got it's a little demo rig that I use when we go and do our live seminars. It's got a little 1-inch steering wheel or so, and it's got a shock sensor on it. It's got a throttle position sensor, and it allows me to do these kind of things and show you exactly what you would see sitting in the seat of your car as you are building these. So with that, let's open up the MXP configuration. And what you're looking at here is you've got all your normal stuff. In this particular case, I don't even have an ECU connected electronically. So we're going to talk about these three sensors right here, and then we're going to build from start. We're going to build at least the steps of it, a fuel level gauge for that is dampened, over time, which is the big problem with the fuel ones that we'll get into in just a moment. So the first one, let's talk about steering. So once you can either set it up, I have it already set up. I'm not going to set up every step, but I'm going to open it up just like we were, and we'll open up steering, and we'll take a look at it. When you first open it up, this will say channel, whatever channel you're on. You have to type in whatever name you want this to be, right? And these are step-by-step directions are in those documents that we've included. Every single screen capture, every single item is discussed, so you can look at it later. But and then you have to tell it what is the function. And in AIM, we've got a long list inside the software of just about anything that you're going to want to accomplish. And so in this particular case, you could go down there and go angle and steering position, right? If it's in ignition, if it's just an angle, it's a generic angle. We're going to pick steering position for our angle, as we showed here. And this one's where it gets a little bit, this is where some people get a little bit confused exactly what they want to do. I just wanted to make sure that you have an idea of what it is. That's one of the reasons we show all of the step-by-steps. But angular pot calibrate, basically you're saying it is an angular potentiometer and we want to calibrate it. That's that are the choices. The other choice is it's an angular pot. Obviously, we're measuring an angle, and it auto calibrates. It starts wherever you push the button to calibrate. That's 0, right? So, but in this case, since it's steering, we want to be able to actually tell it where exactly the different angles are. So we want the calibrate option. We've done some webinars in the past of how to figure out what your sampling frequency should be. In this particular case, I'm one of the tips that we've always shared is probably your driver inputs probably should be at 20 samples per second. You don't want to miss, you know, any important part, and the steering wheel and the throttle and the brake, you know, and all of those things happen fairly quickly. So 20 samples per second will probably capture most of them. Some people will even say that they think that they probably would like to go to 50 samples per second. So you choose you'll use your best judgment, but 20 samples per second is what most people do. You see that this option is grayed out. It's because since we've told it it's an angular pot, the only unit of measure that's available to you is degrees. And then the last one is display precision. You can tell it that I want to have my steering position at 13.7 degrees. Most people will use no decimal place, but again, you have the option. I tend to use no. And then one that's fairly important is down here at the bottom of all of these boxes. It says what you've got a sensor. Yeah, us as AIM, the software needs to quite understand exactly how much travel does this thing have, right? So we're going to be going 180 degrees to 180. It is not hard and fast. It is give us an idea, right? So you don't have to sit there and know exactly, go through a whole bunch of math or measure it and do a bunch of things. Give us an idea, the sensor length or the travel length that it's going to be used. Suspension one is the one when you do the AutoCalibrate. It is very important to have that number exactly correct, and we'll talk about that in a second. Okay, so we get our steering set up, and we save it into the process. Let's go through the next three of them, and then we'll I say that let's just jump in. I'm going to jump in. I'm going to connect to this device, and let's take a look at the steering, and let's make sure. Let me get this kind of set up straight. And when this connects, hopefully it'll connect. Come on, baby. It's thinking. Let's jump out of there and let's try it one more time. Get it to connect. I have the cable maybe not connected in correctly. Back that out. You hear it ding. There we go. Let's try that again. There we go. Come on. There it is. So what we're working on is throttle, right? Is that the one we did? Which one were we doing? I got thrown off a little bit. Somebody in the chat, I think it was either steering or throttle. I think if you could help me out in the chat. Steering, I believe. Perfect. Either way, it'll be what I like to do. Thank you, King. What I like to do is go into the live area. You can do this from a couple of different places, but what I like to do, thank you guys, is when you come into the live measures function after you connect to the gauge, and you find the channels that you've set up are all going to be presented to you here. One of the steps I love to do is just click on it, and it puts the value in real time over here on the right side, and it makes it in yellow, and it makes it just easier for me to find it, especially if my laptop is sitting a little ways away, or we're trying to look at some different things. So there's a couple of different ways to calibrate this. It's the same calibration process, a couple different ways to initiate it. One of them is right in the box itself. If you hover over it, there's that cogged wheel, which is strongly placed all throughout Race Studio 3. And that means there's some options there for you. And if I click on that, you have some options. I can change it to different decimal places. We have some, we can, after the fact, tell it, well, no, I said it was 0, but I'd like to have it to be one place or two. We have what's called a force channel value. We've talked about that a lot in the previous past, but I can actually click on this and tell it it's 90 degrees for. One of the best ways I like to use that for is tell it the RPM is at 8,600 and be able to look at my shift lights on my display. It forces any value of every channel that you want, and then you can actually look on your display and see, make sure your events and your status variables and all the different things that you set up are actually working in the device. Very, very powerful tool, force channel value. But in this case, we want to calibrate it. So if I click on the calibrate button, we've got our steering. And this is a process, it could be, it's set up to do anything that has a point A, point B calibration. Since I've named it steering, it says steering across the top. So in this case, I reach down to my steering wheel in my car. Thank you, Jeff. And if I turn the, let me back up a second. It's asking for my limits. Point A. Point A is by convention for most of us, most people that I chat with especially, left-hand turns are negative. Right-hand turns are positive. So we want our point A is going to be our left turn. How far am I going to turn the steering wheel before I set that point where it starts to compare? It knows millivolts equals, in this case, 180 degrees on my steering wheel. So I type in 180. You could do 90. There are some people that'll have a car, some of these open wheel cars, they just don't turn that far, right? So you maybe you're going to use 20 to 20. It all depends on what it is, but I find 180 on a sedan typically is very, very easy. You can, there's your steering wheel, and you have it set up in such a way that normal setup of the steering wheel, you can easily see 180 degrees visually. You don't have to measure anything. So if you turn it to 180 degrees, turn my steering wheel, I've done that, and you set point A. Now 180 equals 2,772 millivolts in the sensor. And it's the next point is turn to set point B. So I'm going to turn my steering wheel 180 degrees to the right in this case, because that's what I've told it. And you set point B. And then you save it. And then you, once you've saved that, you notice that my live measures now is reading directly what my steering wheel sensor is doing that I am manipulating here inside the car. Okay. Let's say something went horribly wrong. Maybe you told the sensor was wrong. You've got it all done, and you go, the team is waiting for me to get the car out there. I don't have time to redo everything, but I screwed up, and right is left, left is right. One of the kind of the cool little tricks here that maybe a lot of people don't know is that you can come in here and just, okay, I screwed that up. It's going the wrong way, and I really want to get out on the track. Let's just reverse the calibration. So if I reverse that calibration now, I'm turning to the right and it's reading negative numbers, and I'm turning to the left and it's reading positive numbers. Whatever works for you, right? If you have some options here in order to do some different things. So that is the steering option. So the pretty straightforward. I'll close it out with, there's always that discussion of, do people like to do their steering on the steering wheel, or do they like to do it on the spindle angles? I've always kind of seen that as a driver input thing versus what an engineer wants to see, right? And the engineers kind of all want to see what your spindle angles are, and and driver coaches, most people want to know exactly how much input the driver put in. So when you set that up, if you wanted to do it in a different way, you could come in and then you change, and instead of setting up 180 degrees here, maybe it's 10 degrees left, 10 degrees right. You put it on your plates on your scales, and you turn 10 degrees and set them that way. So you have some options to do that, and that's the steering one. Let's jump back into our channels, and let's talk about throttle next. So if I open up throttle, it's virtually the same dialog box. You're going to see as we kind of roll through this, you're going to see that the throttle one, you need to name it what you want it to be named. It's always going to come up as channel 04. We're going to do that one fully in the fuel pressure, fuel level gauge here in a minute. We'll type it all in. Tell it if it's analog or digital. There, in most cases, for what you're going to be doing, it's analog. And then this one here, that again, it's not a great naming structure for what you and I might do, but I want to make sure you know exactly what is the right one to pick. Percent throttle load seems to be the one. This one you can actually do in a number of different ways and get some different things. But what I use all the time is percent throttle load, which will give me percentages. There are some other ones that'll give you 0 to 100 in different units, but this is the one that will give me I'm not sure why the term load, but it will actually get you down to the end being exactly what you want. Okay. Percentage pot, and we do want to calibrate it, and we want it in percentage. So that's the sensor that we're selecting. Sample frequency, same thing as with steering. 20, 50, some people 10, right? Yeah, some people like 10. I find a pretty good balance is 20. We're going to get it in percentages, and I do not want a decimal place. Basically, what we've chatted about before. Let's jump now back over to the device and its throttle we're going to work with and show it real quickly. I've got a throttle sensor set up here, so I just highlight throttle. And last time we entered the calibration process through the gear, the icons that are kind of designed just for this are up here above. And a lot of you will be using those probably most of the time. I did want to show you that way. So if you come up here and you hover over these, this button is an icon showing that you need to calibrate this. We want to know first one point, then the other. Click to select a channel and performance calibration. So if I click on that button, it's going to come up with a list of the device you're connected to, how many of those sensors. It's going to show you all of the sensors that you have set up that are set up to be calibrated. In this case, on this particular setup, I've only got the 2, and we've already done steering. So we're going to select throttle, and we're going to pick that one, and it comes up with it starts the process, right? And then so we end up here. What are the values that I want to have at the end as far as driver units or engineering units that we want to see? In this case, 0 to 100%, pretty typical on throttle. So I've typed those in to here, and then my throttle right now is at rest or fully up at the 0 position point. So I am going to set point A. Boom, that one has now been set. I'm going to open the throttle to full. Just like you would be sitting in the car, you put it to the floor. You can see that this slid over here, and now we will hit set point B. And then we can let go and move it around. We can we can save it. We can stop it, abort it. If we noticed right now, it was like, oh, geez, it's reading 100 to 0, right? Because of the way you've got the sensor hooked in or whatever. We could reverse it, but I'm going to save it because we just did it. And then we're going to jump out right back to where we were. And now we're at the throttle. If I reach over here onto my throttle sensor and I slide it up, down a little bit to 46%, 67, full throttle, and the live measures mode is always your go-to at the end of virtually everything you do, in my opinion. I always want to be able to check and make sure that you got what you thought you were going to get, right? And if it didn't work out correctly, at that point you have the option to real quickly adjust it and make sure that you're getting what you want before you go out on track. Okay, that's the throttle position. Andy's asking the question, will we get to nonlinear? The nonlinear one, I'm going to fold that into the fuel level sensor. But you are correct. Most of our situations, you can assume linear on throttle and steering, but maybe you don't want to. And if you don't want to, we will have the option with the custom sensor. We'll chat about that one in just a second. Robbie's typing an answer to the next one. Let's see where that one goes. Okay, so there's throttle and steering, right? So let's go back into our configuration. Suspension is the next one. This is the one you would think that this is the point where it would get more complex, right? But typically, suspension sensors from this part, certainly the mounting is more complex than some other things. But from the calibration side, it's easier, right? And we'll talk about it. So let's open up the throttle position. I'm sorry, in this case, FL suspension, front left, right? You need to, if you're going to have 4 of them, you're going to need to give them a distinguishing name. So I'm going to let's open up the suspension sensor and let's talk about the settings here. Basically the same as what you've just seen in the past, but we're pick some different choices. First, it's the shock position, right? So you come in underneath the list, it's under position, and then it's is it position? What kind of position? Well, it's shock position is the one that I find the best one to do, but you can do some other ones. We give lots of different options, but shock position is the one that you're going to want for this particular case. We are now giving, and this is a little bit different than what we've done in the past, the position. We're actually asking you, okay, well, what is the position of the sensor you're working with? all working into future power of the software being able to not worry as much about channel names, but actually channel, the positions of things, right? And a more bigger picture thing. So in this case, it was the front left. So I've selected that. I'm gonna cancel out of that. Front left. The sensor type. This is one, again, it's you may look at that. This one does have, you can see the logic in this one. Position, where we're trying to measure the shock position. It's a potentiometer, pot, and auto-calibrate. And that's the way we do suspension typically, is we auto-calibrate them. I've had some racers, some teams that want to do it in other ways, but the most common is auto-calibration. Frequency, up to debate, right? Depending on who you chat with, but that same previous webinar where we talk about sampling rates, we've talked about some of the reasons you might want to go a higher number, but 200 samples per second seems to be a pretty good balance, where you can actually, certainly you're measuring the platform, you're seeing the curves, you're doing all the different things. You may not get the absolute pure accuracy of velocities, because it may miss a couple of data points at 200 versus 1,000 samples per second or 500. But 200 is a lot of people will use that or 500 is typically. But if you forget this and you leave it at 20 hertz, which is kind of the standard frequency value that is by default in the software, you're gonna to the point where that is almost unusable for suspension data if you gather it at that rate, right? So and now a couple of really important ones. Millimeters, the unit of measure, is what do you want to see it in as a final product to you? That is going to change what you put down here in the bottom. So it's kind of funny. I use imperial units, inches or tenths of inches typically in almost everything that I like to do, wheelbase measuring and different things. But when it comes to suspension, I've always used millimeters. We can do our mixed units this way. Not that big of a deal, but pick what you want, right? Not a big deal. I'm going to leave it in millimeters for this particular example, but you can use inches as well. And when you select that, this one becomes, on a shock sensor, becomes a very important tool, because we're doing the auto calibration. It needs to know the length of travel of that suspension potentiometer. And in this case, it's a 100 millimeter potentiometer. If you selected inches, you got to do the conversion and tell the software. It'll try to do it for you, but how many inches is the travel of that potentiometer that you used? So you'd need to convert 100 millimeters to inches. Type that in down there. Okay. That one is linked to this one, and they're very important on the because of the auto calibration. It needs to know where it's at in its stroke. Okay. And then the display precision, no decimal place. That would not be probably what I would want. I probably would want a 1 decimal place, something like that. Pick your choice. You do what works for you. So I'm going to pick 1. And there we go. And now I scan over this, and everything is fine. Let's go ahead and save it. I'm not going to do it right now just for timing reasons, but of course we have just changed it on the in Race Studio 3. The data logger is connected, but all of those changes have not been sent over yet. So typically you would next step would be to transmit. And now let's go back to live, and let's get rid of throttle, and let's highlight our front left suspension and get it to light up for us. And let's get rid of that one. Okay, so now you put the car. The calibration process for this is different than the other two that we already talked about. So this one here typically is you'll be working on your car. You change the rake, you change the ride height, you change, put a little more crossweight in, whatever it is you've done. And of course, it's typically on the scales or a flat level area where you're doing your measurements. Put the driver's weight in it, half a tank of fuel, however you do your process. But you get the thing as it's going to go out on track, and then you start the process of this auto calibration procedure. This icon over here is the click to perform auto calibration for any channels that are on your logger that can just be with a simple click auto calibrated. And that happens to be, I'm going to just go ahead and click on this. There we go. It opened up a list of all of the channels, and you'll notice that there are 6 other ones that we didn't talk about, but all of the accelerometers and the gyros are the roll rates, the pitch, roll, yaw, and my shock sensor are all set up to be auto calibrate. So you get the car where flat is, you just simply come in here, and it's you'll notice that it's 15 degrees, I'm sorry, 15.4 or 5 millimeters negative sitting there. My accelerometers are not zeroed out at this point, and my gyros and my degrees per second values in all 3 axes are not zeroed out. Simply let the car settle, sit there, and then auto calibrate all. You'll notice that they all just zeroed themselves out and exit, right? And now when we come back in here, we can look at our inline acceleration, laterals, verticals, and of course the suspension, which is the one we were working on. They move around just a little bit. The car is, settling, and my desk is moving a little bit as we tinker here. 0.1 millimeter. Okay, and now if I reach over here and I cycle through the shock sensor, you can see that it's connected and it's working. So it's kind of counterintuitive at some level, but the suspension, while a little harder to mount and get everything working, it is very, very quick to auto calibrate, which is helpful for a data guy if you're working for a team and they have made some big changes and you want to zero out all 4 shock sensors before they go out. And they're sitting there waiting to go out on track, and you can very, very quickly get connected, Wi-Fi or cable, and click on this button real quickly, auto calibrate all, and then say go. Right? It's a very, very quick process. Okay, perfect. Andy asked, do you normally have all suspension channels reading 0 at static ride height? To me, if you're do you normally, you're asking me, yes, that's how I have always done it. And I know there's a bunch of people that do that, many folks that do the same exact thing. Set it at that, and then your droop, or when the shock goes into droop, it's negative values. As the car goes up in the air or the tire droops down, it's negative values. It's positive when it comes in. You set all 4 the same way. You can then very quickly see if the car is in, if there's pitch or roll, and very, very quickly see the difference. Some others may do it in a different way, but I think that's pretty typical. Okay, so we've spent about half of our time talking about those 3, and I really wanted to kind of cover those. Those are the 3 main ones, right? But there's one that I get a question with quite a bit, and it's fuel level. So I'm going to jump back into here, and I'm going to jump back actually into the presentation. Let's talk about these fuel level sensors. Fuel level sensors are going to need to work differently, right? And it's a custom sensor. If you do not have some data coming from your ECU based information, the stock car's fuel level, that you have to put a sensor in there, or there's a sensor in your stock tank. I'm going to tell you, we see these all the time in spec Miatas, spec E46, spec, tons of different street cars that they've pulled the stock dash out, put an AIM display dash data logger in there, and yet they still want fuel level for very good reasons. So now we've got a stock tank typically, and we've got a sensor in there that is not dampened at all. And that sensor, as you're driving around the track, is every time you move the car, you hit the brakes, the fuel sloshes around. There are no baffles typically. I mean, there's some probably, but not like a racing cell that has lots of baffles with foam built, in it and all of that. Fuel is moving all over. The fuel gauge in stock form is almost useless, right? A problem we've known about for years. Racers have ran into for years. The Iron Canyon, our friends over at Iron Canyon Motorsports, they have a fuel sensor that they've been selling for years, and it does some pretty cool stuff. Again, years of endurance racers have been using this, and we can do this in conjunction with the Iron Canyon sensor. But what it does is it just takes some time. It takes your sensor is just moving all over with the fuel level that's sloshing around inside your tank, and then it takes it and averages that out over time. But in the while Iron Canyon does a great job and many people will use it, many people do that and use this, or just use this particular process in conjunction with, right? So we'll talk a little bit more about that and show you how it kind of works. But what we're really trying to do is get the sensor data that's coming out of the tank, and it comes out in resistance, because you probably don't want voltage in your tank, although I know there are a lot of cars nowadays that are doing that as well. But typically it's coming out as a resistance. We have to add a resistor to that and convert that to millivolts. I'm not going to go deeply into that process, but if you have a specific need to do that, we have to measure that, figure out exactly what resistor is and put it in the appropriate spot in our wiring. And then now all of a sudden you're getting a millivolt range. Okay, and then now we are getting that value, and it's got this ton of slosh. It's moving all over the place. It is reacting so quickly you can't. It's useless while out on track, and it's useless in the data, because if you download the data with it raw, you're going to see stuff. It's going to be 100 to 0 every tenth of a second, right? Because it's moving all over. So so what do? We need an anti-slosh system, right? So what we Iron Canyon did it, but it's not adjustable for you. So we're going to give you some options where you can create this fuel level sensor and apply this anti-slosh value to it. Okay, so we need you to gather the fuel levels, and we need to read those measures. We need to connect it. We need to help you if you don't know, but they're pretty well known nowadays, which how to get it the hardware connected itself. And so then what we need to do at that point is jump into RayStudio 3 and connect to that sensor. I'm going to do that here in just a moment. Let's walk through the steps, and then we'll come back and we'll show it. Create the RayStudio 3 custom fuel sensor level sensor after we know what those measures are. We'll talk about that in a moment. Configure the analog channel as a fuel level sensor. We'll do that here in just a second. Set the sampling frequency and the measure filter level. This is what's added as a different item when you select fuel level that you may not have seen in any of the rest of the channel settings dialog boxes. And there's a document. I know Robbie's already linked it here that we have in our FAQ site that talks about this process as well. So there's a little bit of background information that you can read and watch this video and help you do this if it's of interest to you. Okay, let's now jump out and let's jump into RayStudio 3, and let's take a look at what this actually looks like as we're doing it. There we go. Okay, so let's go back into our live measures. I've got a sensor set up over here. Let's get rid of that one. And where's my fuel level? I'm going to put it on channel 4 eventually. So I'm going to open that up. And here we are is where we are in the step, right? You mechanically or electronically, you've connected the cable to your top of the tank, the fuel sensor. You've figured out that resistor. You're getting millivolts from the tank. That's the step we are at right now. Okay. Then what you have to do is, because every tank is different, and even production tanks vary, right? So if you got a spec Miata, you've got a BMW, you've got a square rectangular box. The best way to do this is you drain the tank down to empty. You turn this on, you connect your aim logger like I am right now. You're looking at millivolts of an empty tank. Okay, you take your gas can, you measure individual pieces of data. Some people will just say 0. I just want a 0 number and I want a full number and just let it interpolate the value in between. That works if you've got a perfectly square rectangular fuel cell, right? But if your tank has any change of shape as it's moving around, if it's oval, if it's lots of fuel cells in different kinds of cars have little windows, little space saving areas where they're storing fuel all around. Some of them are certainly not square, they're tapered. If you just do a bottom and the top, you may not, a single point interpolation, a 2-point interpolation is not going to get you the values that are very accurate anywhere except full and empty. So what you want to do typically is when you're empty like we are, dump in a measured amount. Typically here in the States, we'll use 1 gallon. I think the document that is built with liters in mind that is linked there, or is linked in our YouTube down below the FAQ page, is I think they say 3 liters. Dump in a certain amount, measure that, and then I've got a sensor over here that I'm just going to kind of twist it a little bit. You're going to see that that millivolt value just changed. And you're going to go, okay, millivolt value 2170. It moves around just with the noise and the movement of the car. Watch it for a second, get an idea of what it is. 2174 equals 1 gallon. Add another gallon of fuel. 2250 equals 2 gallons of fuel, and continue on. If you want it to be super granular, maybe you do half-gallon increments. If certainly may be overkill, but maybe you do 2-gallon increments or 3-gallon increments, whatever works for you, whatever you're comfortable with. This is how you're doing it. You're putting it into live measures, have the channel set up as it is box stock. If we come back over here from Ray Studio 3, when you first open up a channel, this is what it looks like by default. If it's not set up this way, you've plugged the fuel level into an old temperature sensor, one you've used as a temperature sensor in the past. Change it to this analog. You want voltage as your channel, right? You just want to use voltage. You want to use just generic 0 to 5. You want it to read out in millivolts, and maybe sampling every 20 hertz. That's default. Set it up this way, then you're going to be getting your millivolt values out of your live measures. Okay. There's a couple other ways to do that. If you didn't want to, we can actually also turn on millivolt values here if you have it set up as a different channel if you wanted to. But many of you, it's a brand new channel you're going to be hooking up. This will be right out of the box. Okay. We walk that way through that entire process. Then what we want to do is, what we need to do next is take all those data points. And Andy, this is how you would do a steering sensor if it was nonlinear. This is how you would do a suspension sensor if it's running through linkage. You would, instead of just picking a potentiometer, a linear pot, you would create a custom sensor first with all your data points, and then you would use that as your sensor. It's the same step we're going to follow right now, but you would be doing it with steering or with whatever the sensor you were going to be creating. You come into our custom sensor area, and I've created a sensor here that I've already built, created with all this just to save time. But I'm going to open this up, and here is what a sensor might look like when you get it done. We've come in, we've told it its volume. You have some options when you first do this. You've created a new one, and it's blank when you first started, and it might it'll only have two data points in it, point number 1 and point number 2. It's assuming that it's going to be a brand new one with just 2 points. If you want to add more, all you got to do is come in. If I wanted to add one more down here at the end for 15, just hit the plus sign. It would add one more down here, and we could change that value. So as many data points as you determined, and I think 25 is the max, you go ahead and you just keep on clicking on the plus sign till you get the number of data points that you have measured, of gallon at a time in our example, gallon at a time here, especially down at the bottom. You can see that we'll talk about why 2 0 points here in just a second. 1, 2, 3, 4, 5, 6, 7, 8, and then I went to 2 gallons at a time, then 10, 12, 14, 16, because it's near the top of the tank. Probably not as critical that that we want to get that exactly right. Millivolts don't change, but you have the option here of selecting what unit of value you're going to be using. Is it liters, is it gallons, or is it a UK gallon? Okay, we're going to use gallons here in our example. The calibration type, I don't want it to be calibrated. These are the numbers. When it sees this millivolts, I want it to output this level of number of gallons in the tank. So there is no calibration. Here is where we can help you calculate up that ohm value resistor that you're looking for, and then we plug in the numbers, and you'll see this non-linear path of data points come up. That whenever it sees this millivolts, whenever it sees this millivolt here just above 2380 millivolts, it is 4 gallons or five gallons, I guess would be the right one. So it's a pretty simple basic thing, right? And if your shape of your tank is really wild, you can actually get some of these that look like big S's and different things depending on where the level is of that sensor, depending on how much fuel you've put in. Okay. The other trick that I like to do, and it's not needed, but it works for me, is down at the bottom, 2160 in this particular case that I did here, 2160 equaled 0. When I had the sensor down where there was 0 gallons of fuel in it, it was 2160 millivolts. I always tend to add one more data point, and it's also 0 gallons, but it's at 1900 millivolts. So if it ever drops below the 2160 on the millivolts, if something, it's electronic, sometimes if it sees 2150, 2140 occasionally, it's going to start telling you negative numbers if you did not include this last line of data. So what I'm telling it is it can get all the way down to 1900 millivolts and it's still going to show 0. I've always I see a data point there. I like having negative fuel, making fuel for you. That make me feel warm and fuzzy, but but then my engineering mind goes, oh, well, that's stupid. That ain't right. So here I am building that into it. And I do the same thing at the top. If I know it's a 16-gallon tank, I typically want to stop that from reading 16.8 on a slosh, or if something happened. So I'll put a number up that's high as I think the sensor will ever go. And I plug in 16 gallons at 3100. Now you could put 5000 in this value, and I could put 0 millivolts down here, but it makes the linear numbers we're looking at become very, very steep, and it scales it in such a way it's a little harder to read. So I just left it at a little bit less on the ends. Okay. That's how you build your custom sensor. Give it a name. We're going to save as, I'm sorry. And I've called this one Webinar Fuel Level Sensor. Pretty straightforward, right? So I'm not going to close out of that. I'm just going to jump back into my configuration, and let's change channel 4 to accept, and this is one of the questions I got where we didn't cover this connection. One time we mentioned this in the past. So how do I configure this? It's different than every other one I've ever done, right? So let's change channel 4 into a fuel level sensor, right? So I just clicked on it. We're going to come in here and we're going to come in and type fuel level. Typing while on camera, this is always a good thing, right? And then what is the function? In this case, it's volume, right? If we come over here, we can have just a straight up volume generic, or one of the options they give us is fuel level. So I'm going to go ahead and pick the fuel level as my value, fuel level. You'll notice it's changed a few things down here from what we normally see. The first one is sampling frequency. We have these things where we've talked about 20 as like a minimum. Yeah, we can do 10, 20, maybe it's even 50 that we want to see. Fuel level is its own different animal. So I want to really kind of hit on this a little bit at first. So I'm going to come back to that one. Let's change it to our outputs just to kind of clean all this up. We're here in the States, we're going to use gallons. How many decimal places? I'm just going to say to the 10th of a gallon. And now we've got the sampling frequency and our measure filter level. These are two things we still have to set. Let's chat about that, right? So if we come in here, we have our normal, abnormal number of channels that are available to us as a fuel level sensor. It's fuel level. AIM, the software has been thinned down to say, we know what you're doing with it. There is no reason to grab this at 500 hertz, right? So they're saying, well, do you want it every half a second, or every second? Do you want us to go out, sense it, and then perform some sort of a filter on it? I'm going to say 2 hertz. I'll just leave it at standard practice for right now. And then what filter do we want that? Think of this as anti-slosh. Think of this as averaging over time. And if we come in here and I click on this, we've got these low pass filters we can apply. And we can say, okay, only look at the last 2 seconds, and that's what we want outputted. So every half a second, it's taking a reading, and then it goes back and looks at the last 2 seconds worth, and that's what it's the gauge is, and the gauge is doing this in real time. It's the work is being done on the gauge because you as a driver want to be able to see this while you're driving, not just later in the data? Or do we want to average the last 4 seconds, 8, 16, or 32? So you can average out the last 32 seconds of data if you're gathering data at 2 hertz. If we come back in here and we tell it, okay, well, let's only gather it one sample per second, you'll notice that the options here have changed. Since the gauge itself is doing the work, we want to make sure we don't overwhelm the hardware with a ton of work, right? We don't want to tell it we want to look at 512 seconds worth of data or something, right? So you'll notice that these values here are double than that they were at 2 hertz. You make the choice. Try it out a couple times. I've found that different sensors and different tanks are bouncing around different amounts. You want to apply the least amount of filtering to get what you want, because we are taking data and manipulating it at some level. So to give you what you need. So I'm going to say let's do it. Let's do it at 1 hertz, and let's crunch it. Have it look as far back as we can. 64 seconds of data, and then it's going to show us that those values. Okay, so we've got this all set up. What we would Robbie makes a good note, and I agree with that. I wanted to kind of over exaggerate it here a little bit, but the typical way I have found has had good luck is 2 hertz and 16 seconds of filter. I would do, that's probably where I would start as well. Thank you, Robbie, for mentioning that again. That will help. Okay, but for this demonstration, I wanted to filter it quite a bit. Okay, boom, we've got that in there. The fuel level is in there. All of these things are now set up. I'm going to save this calibrate this configuration, the entire configuration, because we changed some other things. And now I want to transmit that into my into the MXP that I've got sitting here. Perfect. I'm reading a couple of questions here while that is transmitting. It's going to pop up here and say that it's done. Kyle says, can you add a data point later and scale in between the 2 existing ones? Absolutely. Just jump back into your custom sensor. Jump in there and if you wanted to add a 3.5, you just come in here, click on that plus sign. It's going to put one in between, type in the information, and resave it, and then transmit it back into the logger. Remember, everything we're doing on Race Studio 3 is there, and we've got to transmit that in because that particular custom sensor is being used in real time on the gauge. So you'd have to retransmit in, obviously, but all doable. Okay, so now what we've got is we've got our system is now set up, and let's jump into our devices, our real-time view of this, and let's get our live measures. And now we've got a fuel level sensor over here. Okay, remember we just told it millivolts equals so many gallons with a 10th to the 10th of a second. 10th of a gallon. And then the sensor that I've got set up over here, I'm going to go ahead and just turn it a little bit, and you'll see that it will change. I'm going to go from full to from 6.3, and we're going to head towards a full tank of fuel as I kind of turn it. Let's turn that all the way up here, and you're going to see that it's going to slowly build. Now, I'm not moving the sensor at this point, right? But since it's averaging back, it's slowly coming up. So if it's too slow for what might be of use to you, I have set it up to be pretty darn slow, right? With the averaging that I use, 64 seconds of data it's looking back on. That might be too slow for you. Robbie's suggestion, Robbie and I have worked on this with several of our users, some of them together, that 2 hertz and 16 seconds is probably a great place on a endurance race car with a stock tank, a Spec Miata, or whatever it happens to be. A lot of those cars out there. So you'll see that it just kind of continues to rise. So the fuel level, an interesting sensor. I wanted to kind of go through it, give everybody a pretty good idea of what of how that thing works. I'm going to turn it down a little bit. One last thing that I thought I would show, and we're just a couple of minutes, but from being at the end, is I wanted to go back into the configuration, and we've certainly touched upon this a few times in the past, but I thought it might be kind of fun to show you one more time. What I'm seeing on my gauge over here is I've set up a couple of alarms. In this case, these are the only alarms. I don't have low oil pressure or anything else, just to keep it as clean as we can. But when the fuel level is normal, I've set up an alarm that is saying if the fuel level is greater than 3 gallons, you could make even a third one here, but anything above 3, the text, the gallon value on my screen of the fuel level channel is green. So as you're racing along out there and you're using your peripheral vision to see this, you could have anything from 16 to 3 is going to be green. And then as soon as that value drops below the value of, oops, don't do that. The value of less than 3 gallons, that value goes to red on your display. So you don't have to have a light come on. You might want to too, depending on how it all works out. But you can see that. Okay. So maybe for some of you, maybe the next logical point would be anything down to depending on how good your tank is of picking up fuel. Maybe it's down to 4 gallons is green, 4 to 2 is yellow, and 2 and below is red. And then a message starts to come up or something when the fuel pressure drops, or the first time you start seeing fuel pressure dropping, something like that. Okay. Just another way of tying that together with the end product of how you are seeing it on your display. Okay. Perfect. Let's see. Let's cancel out of that one. Perfect. Any other? Start thinking of if there's any other questions you might want to ask as we kind of close this one up. Is there a way of smoothing out RPM data coming? Oops, Robbie got that one. The answer to that I would think is yes. Well, talking about alarms, is there any news on the increase? Let's let. I do not know the answer to that. Let's see if we can dig into that. I think there is some discussion of that happening. Okay, and let's jump back into the presentation. So to kind of just cover that just a little bit real quickly, you on the fuel level, you need to connect it, add that resistor, change it from resistance to millivolts, and then we need to connect RayStudio 3 to read those values of that individual amounts, 1 gallon at a time in my example, get the millivolts, create that RayStudio 3 custom sensor. So you have it, name it, whatever it happens to be. You know what? I didn't show that. Let me show that. That was one of the questions I had before, and I didn't go there. So let me go there real quickly. If I go in here and I open this up, remember we have a fuel level, and then if you need to pick the sensor that you just built, it'll be your name, right? So in my case, I've got three different custom sensors that I have built, and you need to pick the one that is the sensor that you built under the sensor column here. Make sure you select that and then save it, and of course transmit it. And then that was a step that we didn't show last time. I just recalled that. Make sure you select the custom sensor you built. It will be shown by the name that you used. Okay. And then you save that and save that out of there and save it and transmit it in, and then you're using that custom sensor to do your values. Okay, let's bring this back up and let's kind of close this down a little bit. You configure that analog channel as a fuel sensor. Of course, you select that new sensor you just made. Set that sampling frequency and measure filter, be it the 1 and 64, the 2 and the 20. I'm going to tell you that I've seen enough different variances that Robbie's idea of 2 and 16, 2 hertz on the sampling frequency and 16 on the measuring level, measure filter level is a pretty darn good place to start, but you may want to add more or take some away depending on your tank, your car, your use. Okay. And again, there's a document out there that kind of explains a little bit, even some more of the technical details behind all of that. And we went ahead and jumped out and we did that. Perfect. I think think we covered quite a bit pretty quick, as we always do here, right? We go through a lot of value, a lot of information real quickly, assuming that you have the ability to jump back in and rewatch the video. We want to get as much information out as we can, and knowing that if you missed a little bit of it, you can go back and grab it, hopefully. And of course, give us a call and we'll help you walk through the rest of it if there's something we missed. This one is going to be just as soon as it gets taken out of our webinar materials and we can crunch it into the video and get it sent up and placed up on YouTube. This video will be joining the rest of them to make about 185 videos that we have up on YouTube. The tons of information there, all of our webinars, of course, and tons of other ones as well. So the Kyle asked, to be clear, can the 25-point calibration table be applied to any sensor and channel? And to be clear, yes, you are building the custom sensor, and you can apply it to any use you wish. So yes, that is a yes. We're a customer support company that happens to sell racing electronics, and our guys are out there. I know a bunch of folks were out last weekend. Looking forward to seeing everybody at the racetrack. We're gonna just reminder that we're going to be at the Performance Racing Industry Show in Indianapolis coming up here in about a month or so. If we have a big presence there, big booth. A lot of our Italian friends you've all met Emiliano here doing different things. He certainly will be over visiting with us, and you can all meet and chat with him face to face. So come chat with all of us. We'll be at the PRI show, plus of course other trackside events coming up. All going to be great. We do not have a webinar this coming week. I mentioned that offline just a little bit earlier. It's here in the United States. It's our Thanksgiving week, so we're gonna skip on Thursday. A lot of people traveling, but on November 30th, we're going to have another chat with Larry McReynolds. Larry McReynolds, standing right here, is a crew chief in the NASCAR world. Was for years, winning crew chief, Daytona 500s and championships with many different drivers. Is going to come join us. He about a year or so ago he joined us, and he had a good time, and he's excited to come back and chat a little bit more. We talked last time about historical use of data. He was a crew chief when in this Buick right here, this Quaker State car, when data first came in, the first time he ever saw it, and he talked about that story. If you want to find the YouTube link, maybe Robbie can find it. We'll certainly have it in the YouTube description of our first chat with Larry. And he talked about when he first started using data, some of the stuff that they did with it, some interesting stories. He is a world-class storyteller of all different types of stories. He has gone from being a crew chief to being a race analyst for half of the year during the TV presentation of the NASCAR events here in the States. So very, very good storyteller. He'll be joining us not next Tuesday, but the following Tuesday, November 30th, which is our next webinar Larry has a live radio show that he does every day during the week. So he will be joining us about 10:10 Pacific, about 1:10 p.m. Eastern. He has to finish up his Sirius XM radio show and then jump online with us. So it'll be just a few minutes after we normally start. So looking forward to that. It'll be a great time. Larry, tons and tons of great comments from Larry joining us last time. And we hope to have a few more larger name guests like that over during this winter time as well coming up. So here's some contact information about some of the stuff we about me, but about to get back with me on if we didn't cover something exactly as you might didn't quite get the information to you the way you need it, give me a holler. Roger@aimsports.com. Look forward to chatting with anybody that about this or any other questions you might have. Hope everybody has a great holiday, and we'll see you guys all on a couple weeks from now for the next webinar. Thanks everybody for coming. Look forward to seeing you next time. Talk to you soon.